This is 6.7. It's going to be the last section in this chapter. And I have a couple more formulas to teach you. The first is the volume of a sphere. So the volume of a sphere, and I don't have any fancy way to remember this, is 4/3 pi r cubed. And we know it's a volume because it is r cubed. So in this case, the sphere is 6.4 millimeters. So the volume is going to be 4/3 times 3.14 times 6.4 millimeters cubed. So I'm going to plug all that into my calculator. 4/3 times 3.14 times 6.4 cubed. And I get 1097.5. And because it is millimeters cubed, we have a volume. Okay. So before I teach you the next formula, let's think about a rectangular prism. The volume of that prism is length times width times height. And one way to think of that is to think of it as the area of the base. So length times width is the base, and then we just multiply that by the height. Okay? But what if I built a pyramid inside of that? So let's see if I can draw this. So let's say a pyramid touches there, and it connects there, and there, and there, and there. So the base of the pyramid is still the same. Not half, a third. So the volume of that pyramid is going to be 1/3 of the length times the width times the height. Okay, so you can sort of look at it as this empty space and this empty space and the pyramid all have the same size. They're all the same volume. So if I sort of cut this right down that line right there, then this side of the pyramid is going to be half as big as this empty space, and that side of the pyramid is going to be half as big as that empty space. So we essentially have three volumes that are equivalent to the pyramid, the left, the right, and the pyramid itself. So the formula is 1/3 times the base times the height. Okay, well, what if we had a cylinder? Well, the formula still works, base times height. So if this radius was 5, then the area of the base is 3.14 times 5 squared. That is the area of a circle. And then we just multiply it by the height, 3.14 times 5 squared times 15, and that's going to be a volume. Okay? And that formula works for cylinders, it works for rectangular prisms, it also works for triangular prisms. Find the area of the base and then multiply it by the height. Okay? Well, what if I put a cone inside of this? Let's see if I can draw the cone. So that cone looks like this. How do you think the area of that cone is going to compare to the volume of the cylinder? Well, it's exactly 1/3 as big, just like the pyramid. So if this is the area, if this is the area of the base, I can multiply it by the height, and that turns into volume of the cylinder. And if I times that by 1/3, that will give me the volume of the cone inside that. As long as the cone touches there, then that is the volume. And it turns out we don't really care where it touches. If it was some wonky cone that hit here, 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 the volume is going to be the same. Same with your pyramids. So if my pyramid touched right there, it turns out that the volume is going to be the same. All right. So volume of a cylinder, the area of the base is going to be 3.14 times 4 feet squared. That gives me this area. Then I multiply it by the height. And you'll notice I have 1, 2, 3 copies of feet. So this is going to be a volume. That is the volume of the entire cylinder. Oh, there's no cone in this one. So that's just going to be the answer. Oh, we don't want this one. Okay. Volume of a cone. So we pretend that it's a cylinder. So the area of the base is 3.14 times 3 yards squared. And then we multiply it by the height, 11 yards. And that's where my yards to the third comes from. And then the cone is simply 1/3 as large as all of that. Okay. All right. A company makes chocolate candies in the shape of a solid sphere. Each piece of candy has a diameter of 6 centimeters. If a box contains 20 pieces of candy, how many chocolates does the box contain? All right, so here's my candy. The centimeter, or sorry, the radius is 6 centimeters. So the volume of that chocolate is going to be 4/3 times 3.14 times 6 to the third. Okay. So 4/3 times 3.14 times 6 to the third. I get 904.32 centimeters. Okay, centimeters cubed. Okay. So the box contains 20 pieces of candy, so what should I do to figure out the total volume of the chocolate? We'll just times that by 20. That's a lot of chocolate, by the way. That would, I mean, that sphere right there is pretty close. Oh, oops, I made a mistake. Where's my mistake? Diameter. So I need to change this to a 3. So 4/3 times 3.14 times 3 cubed times 20. Okay, that's much smaller. Chocolates. All right, that is it. Get to work.